This is question number 9 in the textbook, chapter 16. It says, what is the total charge of all the electrons in 1 kilogram of water? There are kind of two different ways of approaching this. So I've gone ahead and worked out kind of the first way, starting here. The first way is to simply kind of use a bunch of conversions. So I've used our train tracks. First thing we have to do is find the molar mass of water. You can find, the molecular mass. Since the average atomic mass of oxygen is 16 and hydrogens are 1 each, that gives you a total of 18 grams per mole. And so once you have your molar mass, then you'll convert from moles to molecules. So now we have a certain amount of molecules in 1 kilogram of water, and then finally, second to last, we'll then go from moles to electron. Well, we're not going to go from moles to electrons, but we've got in 1 mole, we've got 10 electrons, and each electron has a charge of 1.6 times 10 to the negative 19 coulombs. That's the fundamental charge found by Robert Millikan in the oil drop experiment. And when you do it that way, you get negative 5.4 times 10 to the 7th coulombs. 5.4 times 10 to the 7th coulombs. And I think there's a kind of another approach to doing it, certainly one that makes sense to me as well. Is you could say, all right, well, there are 10 electrons in each molecule. By the way, be careful with your Lewis dot structure if that's kind of how you're figuring out electrons. If you figured out oxygen has 6, but that's valence electrons, of course, each one of those is going to be bonded here covalently with a hydrogen. So the shared outer shell electrons are only 8, but that's the second level for oxygen. There are 2 more additionally in its first level. So therefore, there's a total of 10 electrons in a complete molecule of H2O. So I would say with that, that'd be another direction to go in. We could say that there's 10 electrons in 1 molecule, in 1 H2O, 1 molecule of it. And we could then, from there, we could say, all right, well, 1 molecule of H2O, I should be careful because, of course, that's close to a mole. 1 molecule of H2O has 18 atomic mass units. And of course, I can get that by simply adding oxygen, which is 16, plus the 2 hydrogens. And then there's a conversion factor between atomic mass units and kilograms. And 1 AMU is equal to 1.66 times 10 to the minus 27 kg. And that's a fundamental given to you in the, it's a conversion factor, sorry, given to you in the front cover of the textbook, or you could just look it up online. So now we've got kilograms, and then finally we could say, all right, well, we've got 1 kilogram of water. So that'd kind of be another way or another approach. We'd see again that all of these guys cancel out. We've got electrons. The only thing that we haven't done, so hold on, molecules of water. Let me do this in green. Oops. Molecules of water, AMUs, kilograms. And so now I'm left with total electrons, and I need to multiply that by the charge of a single electron. So I'll add one more term to the end of this fraction. I'll say that 1 electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. And that will take you to the same place that will.